Well, good afternoon, everyone. I want to thank everyone for joining us here today. I'm Ryan Siegel. I'm joined by my colleague, Grant Mosey. We're here with the Smart Energy Design Assistance Center. Today's session is being recorded, and an archive copy of the recording, along with the PDF of today's slides, will be made available on our website, smartenergy.Illinois.edu. And today's session is estimated to run approximately an hour and a half. So we should be wrapped up here by 2:30. I do want to thank the AIA Illinois and Illinois Green, which is part of the U.S. Green Building Council community, for sponsoring today's session. Stacy Finkston and Brian Imus, unfortunately, were not able to join us today. They do want to send their greetings and welcomes for you all. And again, do appreciate you all being here today for this. As I mentioned, I'm Ryan Siegel, joined by Grant Mosey, the SEDAC, housed at the University of Illinois at Urbana-Champaign. For those of you who may need AIA or ICC credit, we will be providing a certificate to all participants after today's session. So you will be able to have those for self-reporting credits. However, if you need ICC or AIA credits, along with that email with your certificate attached, there will be a link to follow so that you can provide your AIA or ICC information, and we can go ahead and get those credits self-reported, or get those credits reported into those organizations for you. If you do have any questions during today's presentation, please use the question and answer window. You can find that towards the bottom of your screen, as indicated here on Q&A. So if you do go ahead and have any questions, do go ahead and put those using the Q&A function. If you do put those in the chat, we might or might not see them. But if you do put them in the Q&A, we will make sure that we are able to see them that way. A little bit about SEDAC and who we are. We are an applied research program, again, housed at the University of Illinois at Urbana-Champaign. And our primary mission is to reduce the energy footprint of Illinois and beyond. And our energy code trainings, of which this is part of, is one way that we look to achieve that goal to help you all in your endeavors to reduce your client's footprint as well. So today is the last of a series that has been put together for the architects. Started with Building Energy Education Fundamentals. The last session was on renewables and zero code, and today's will be on Passivhaus and advanced design. So if you did, again, miss any of those, you can go back and see those. And archive versions and PDFs of our webinars and workshops are available on our website. So for those of you who might have people in your office that might be a little bit earlier in their career, we do have a B fundamentals program. So these are several education modules. So if you're having someone that's struggling specifically with a particular topic, this can be a very useful set of learning materials that you can use. And all of this is free to the end user. We don't charge any additional fees for this educational material. So we do encourage people to take advantage of this as you are able and find opportunities. So, if you do have any questions after today's presentation and you might need some technical support regarding the state of Illinois' energy code, or perhaps even just other good building design, but particularly focused on the state of Illinois' energy code, feel free to reach out to us, energycode@Illinois.edu. We do have an 800 number, so if you do have a real quick question, where do I find such and such in the code, you can use our 800 number, 800-214-7954. But again, we do encourage people to use this email address. This allows us the opportunity to research and provide a more thorough answer for whatever your inquiry is needing. Another advantage to having this is that way you have a good written documented response that can be shared around with the project team, which might even include code officials. So if questions come up, everyone's reading off the same sheet of music, if you are, so to speak. We also do have several online resources at our website, again, smartenergy.Illinois.edu. We're calling out a few of these items here, and some of those we'll touch on a little more in a bit. But we also have a specific energy code section of our website. Again, we do post archive versions as well as upcoming workshops and online webinars. We do have several additional online on-demand training modules. These are designed, again, a little bit more for the beginner in mind, so you don't necessarily need to have a firm grasp on the energy code to be successful in these training modules. They take approximately an hour to an hour and a half to complete any given module, and those are available with continuing education units as well. So people do find that beneficial. We also do have links back to our technical support line. So if you are struggling to find our 800 number or remembering our email address of energycode@Illinois.edu, you can come to our website and we can link you back in with that technical support helpline. Again, we have several different energy code resources, including some descriptions about the Illinois Energy Conservation Code and the Illinois Stretch Code that will be coming to the state of Illinois at the end of 2020, or coming in 2024, along with several frequently asked questions. So if you do have a question and you think, this probably comes up a lot, go ahead and pop over to our frequently asked questions. We also have links to several useful websites. This includes links to the International Code Council's website that hosts the International Energy Conservation Code, which is what the state of Illinois Energy Conservation Code is based upon. Also link over to the amendments for the Illinois Energy Conservation Code and to the Chicago Energy Conservation Code. So regardless of where you are, we are able to provide several different levels and links over to you. We also do have several energy code smart tips. As I mentioned earlier, we do have several resources. Some of these are some energy efficiency basics and some smart tips, along with tech notes. In particular, here we're showing on the screen one about domestic hot water circulation systems. These are different as far as how the code actually requires these to be handled. Previously, we had found domestic hot water recirculation systems that operated 24 hours a day, 7 days a week, regardless of occupancy and demand for water. And the code no longer allows for that. And so there's a great tech note as far as how do you implement a code compliant installation of those. So before I touch on our learning objectives today, I do have a poll here that I want to launch and learn a little bit about our audience today, and asking if you have worked on a Passivhaus project or are you familiar with the Passivhaus Institute US requirements. I just want to get a sense as far as how many of you might be somewhat familiar and how much of this is likely to be some new or substantially new content for you. Just a couple more moments for an answer. Okay. So looks like this is going to be very new material for the majority of you. So that's kind of what we might have anticipated. So about 3/4 of you, this will be your first real encounter. And 1/4 of you have either worked on a Passivhaus project or at least are familiar with the Passivhaus requirements. So, as far as what we're going to be covering today, going to be looking at some of the history and principles of the Passivhaus Institute, looking at some of the use cases for, and particularly what types of products are able to be certified for Passivhaus use, looking to learn also about the actual certification process and some of the tools and supporting guides for implementation. And so with that, I'm going to turn it over to my colleague Grant to talk a little bit about the history and principles.
Thank you, Ryan. So as Ryan mentioned, our talk today is divided largely into 4 pieces. The first of these pieces deals with a little very brief overview of the history of the Passivhaus standards, and then perhaps more importantly, the actual underlying principles of the Passivhaus standards that makes this program unique. So I think when we talk about history, the principles of passive building have been around for as long as humans have been making permanent settlements. So really what we're talking about when we talk about the history of Passivhaus specifically is when these requirements were codified and updated to reflect modern construction standards. So the Passivhaus Institute was actually brought about by a discussion between researchers at a university in Sweden in the late 1980s. These rules were codified in Germany in the 1990s. That's why you'll often see the word Passivhaus written HAUS with that German spelling, because this program was originally developed in Germany. It has since been ported to the United States with the Passivhaus US Institute, and the first building was actually built here in Illinois, in Urbana. That being said, for whatever reason, it has remained a lot more popular in Europe. I know in 2008, there were something like 15,000 to 20,000 Passivhaus certified projects worldwide. By 2010, that was 25,000 in Europe alone. And as you can see, it wasn't until 2012 that the United States actually got a project. So for whatever reason, it's been more popular in Europe than it has in the United States, but we're seeing the popularity in the United States increase, which is actually what precipitated the idea for this kind of presentation. Their underlying principles are a climate-specific standard that works on a principle of climate zones. This was originally defined in the US context in the year 2015. It's updated on 3-year cycles. So most of the information we'll be giving you today uses the 2021 certification manual. So we want to draw your attention to 4 kind of core principles. And at first blush, these may all seem like they're envelope related, but as you see, as we dig into them a little bit more, they deal with all aspects of the building, from envelope to the more operational HVAC components. So I like to think of these as being corresponding to the 3 modes of heat transfer, kind of from your high school physics class, plus this question of moisture and balance. So the thermal comfort, that is, or thermal control, that is your conductive heat transfer, and it's simply a matter of building a tight, well-insulated envelope without thermal bridges. The conductive heat transfer is the air control portion, which is a matter of providing a tight envelope and a balanced mechanical system, and there are standards for what constitutes balance that we'll elaborate on a little bit more as we go on here. Radiation control, that deals with the radiative heat transfer and applies especially to windows, doors, any kind of fenestration or opening elements. And then finally, there's the moisture control component that deals with having a proper vapor and bulk water barrier, and the building having drying capabilities and interior humidity controls, which, as you can imagine, when you're building a super tight, super well insulated building, can become quite important. So the first of these key focal points is thermal control. And I think there are really two components to this addition of thermal control. There's the matter of quantity and there's the matter of quality. So in terms of quantity, generally the insulation requirements for thermal resistance are something like 2 to 3 times the levels typically specified by code. And in one way, it's sort of interesting that it's 2 to 3 and not 5 or 6 or 9 or 10. And really that's because increasing this kind of R value of insulation is subject to the law of diminishing returns. So you get a lot of benefit when you first start increasing your level of thermal resistance, and then the amount of benefit you get gradually tapers off. So as I said, the Passivhaus standards usually mandate a level of insulation that the quantity is 2 or 3 times greater than code minimum levels. Also important in the standard is the quality of the insulation provided. And when I say quality, I mean typically the absence of thermal bridges. So we want to see nice continuous insulation here that is not subject to a lot of interruption by thermally conductive materials. There are some benefits associated with this that are not directly related to heat transfer. As you can imagine, buildings that have a lot of insulation are more durable, more resilient, and tend to have better functioning from a sound attenuation perspective as well. Airtight construction is the second key point of this, and this goes closely with the point we're going to talk about with air balancing. But airtight construction, you can see on the right here, this sort of section with the red line where you want to draw a red line continuously around the entire perimeter of the project, showing where the air barrier is. This is important to ensure proper detailing of the control layers. One thing to keep in mind is this is generally easier to do when you avoid switching between interior and exterior control layers, because every time you move the air barrier from inside of the framing members to outside of the framing members and substrate, you create a potential weak point. So ideally, we try to keep the air control layer interior or exterior, and choose one and stick to it. One interesting thing about Passivhaus that is maybe not as typical as some other standards is that there is a field verification component required that deals with air tightness. So in order to get certification, which you'll see in a little bit more detail later, a blower door test is required, and then the air tightness is also used in the modeling software that's used in the performance-based compliance paths. The big benefit of providing this really tight envelope is to prevent that conductive heat loss or heat gain as air leaks through the building. Some additional benefits that are not directly related to heat transfer are the improvement of humidity control. Obviously, if not a lot of air is moving, not a lot of vapor is moving. Improved durability, the less water intrusion we have into conditioned spaces and into our building's assemblies, the less trouble we're going to have with freeze-thaw cycle and things like that. And then just as we talked about with increasing the amount of insulation, having airtight construction will also have benefits from a sound attenuation perspective. So the third method of heat transfer and the third big principle we're going to talk about is radiation control. And at the simplest level, you can think of this as using best-in-class fenestration for windows and doors. As you can imagine, when we're building this really super insulated, super tight building, anytime we put an opening into that surface, we're essentially introducing a potential failure point or a weak point in our thermal performance. So we want to use the absolute best in class windows and doors to make sure that we are not allowing a lot of heat transfer either conductively or convectively. The placement of these window elements is also very important. when we do design for kind of a passive solar where we're trying to harvest that sunlight, we'll want to use thermal mass as a collector to try to hold on to the heat that is desirable. And then we're also going to have to pay close attention to the directional orientation of this fenestration, as you might anticipate. The fourth, and this deals sort of with the moisture component, but also with the air tightness component, is the idea of balanced ventilation. So key points of this will maintain better air quality. Really how you achieve this is through balancing exhaust and supply air systems. So I think in the standard it says the exhaust air and the intake air should be within 10% of one another from a volume perspective, or should have a difference of no greater than 5 pascals in terms of pressure level. You'll see a lot of energy recovery means, so energy recovery ventilators, enthalpy wheels, things like that. And really this is because when you have a super insulated and airtight envelope, you're really minimizing the amount of natural ventilation that can occur or is supposed to occur. And in one way, this is maybe a little bit of a downside because we like natural ventilation, but in another way, it gives us an extreme degree of control over the air that's emitted and exhausted to the building. If we didn't have this kind of heat recovery, fresh air would definitely be the dominant load in passive houses because their envelopes are so tight and thermally resistive. Before we go on to product certification, I think Ryan has a poll question here. So I'm going to read this aloud just for the benefit of those who are watching this via recording. The question is, what are the 5 core principles of passive house? The choices are thermal insulation, no thermal bridges, air tightness, LED lighting, high performance glazing, and heat recovery ventilation, and high performance heat pumps. So we'll give you just a couple of minutes to weigh in on this.
Again, if you do have questions as we go along, again, feel free to use that Q&A function that you should be able to find towards the bottom of your screen. Looks like we've got most people have answered. Just got a few more, give it a few more seconds here. All right, we'll see how we did here. So it looks like most everyone picked up thermal insulation. Yes, definitely an important one. No thermal bridging, that's a next good one. Very airtight, that's another one. High performance glazing and heat recovery ventilation. So those are the 5 principles. Fortunately, not too many people picked LED lighting and high performance heat pumps and Energy Star appliances. While those generally are found in passive house buildings, it's not one of the core principles behind it. So next up, we're going to talk a little bit about passive house product certification, understanding that not everything in a building is a product that is certified through the Passive House Institute. There are 5 primary items: opaque systems for wall, roof, foundations, and floors. So opaque being we can't see through them. Then we go with windows. Other envelope penetrations are doors and attic hatches, then followed closely by energy recovery systems, and then heat pumps. You'll see some of these are only by the Passive House Institute International and not Passivhaus US yet at this time. So again, first looking at the envelope and really kind of diving into all the different joints and bends in this envelope. And so part of certified opaque systems is they're looking at how applicable is it to the various climate zones. That was a big change between the original Passivhaus standard and the updated versions, as the original Passivhaus standard was developed using a single climate zone, and so everyone used the same standard. However, it was found as Passivhaus was moving to a more global standard and differences in climate, the need for adjusting the standard and what your targets were based on your climate zone became recognized, and so was developed and integrated into the standard. So as part of this is checking to see, okay, what is the various U factor requirements based on your climate zone? U factor is generally or roughly the inverse of R value. U factor is transmission of heat, whereas R value is a resistance to the transfer of heat. So that's where there is a little difference there. And also looking at, okay, what is the interior temperature of surfaces, and particularly focusing on keeping that above condensing temperatures, because we do have very airtight and very controlled envelope environment, and we do have moisture, wanting to make sure that we don't end up with condensing on surfaces. So also checking for the ability to or the inability to generate and holding moisture within the assembly. Again, we're trying not to hold moisture inside an assembly where condensation and oftentimes mold can develop if we do that. And part of this is also being able to detail in the drawings as far as how do, when these materials come together, how do you detail the joints between them? And here in the graphic, we're really calling out, it's not just where, a wall meets a floor or a wall meets a roof, but even here at the top of the roof where I've got two roof panels that are coming together, how am I going to get that detailed joint because I have a bend or a crease, if you will, in that material and that system. And so making sure that we have the ability to detail all these different joints in enough detail that they can be constructed. Something that this also kind of really brings to the forefront is trying to limit how many different joints there are in different aspects of this. This is something that we have found as more and more designs, we've seen much more complex and complicated geometries in the envelope, which when you get to actually trying to construct those assemblies, the more joints you have, the more difficult and the more detailing is going to be required. So as far as windows, Passivhaus US has several certification factors. Here we're calling out for climate zones 4 and 5 that we are here in Illinois. And something that you might be noticing right off the bat is a lot of these, these are in scientific or SI units. We're dealing in square meters and watts. So this is not the imperial factors. So here we have like when they're talking about U factor and U value here, this is not the same as the U factor that you find on the window sticker at your local store, or with your local window dealer. Their U value is not going to be in the same units as this. Now we do have here the conversion from the SI over to U values and vice versa, but there is a substantial difference here. You notice here it's a factor of roughly 5.5 difference between these. So that's quite a substantial difference, and so something to be aware of anytime you're looking at Passivhaus windows. And also here noting, not only calling out the efficiency criteria and the comfort, we commonly through the energy code deal in just the comfort condition. Do you have your good U value? But also with Passivhaus, looking at what is our thermal bridging. Are we introducing substantial thermal bridging as by introducing these windows and these holes in the assembly? And also moisture. And are we managing this moisture and preventing that condensation again? So this is what a sticker might look like here. And so here noting that, again, the U factor and the performance is actually going to vary based on your climate zone, which is something that we don't necessarily think about all the time, is that temperature impacts the U factor and R value of a lot of insulation materials. And so this is part of the modeling that they do, is based on the temperatures that these units are seeing, is identifying, okay, what is the performance within that specific climate zone? And part of this also goes back to, with most windows, the weak point of the window, performance-wise, generally is going to be that perimeter frame. That perimeter frame is where a lot of thermal bridging generally occurs. Thermal bridging, while the center of glass does have some ability to transfer heat, we don't have that thermal bridge in that center of glass. So, part of this is also by selecting this, trying to verify that we're not going to end up with condensation on our windows, because part of this is that here in the state of Illinois, we've got very cold winters, and so trying to if we are maintaining a reasonable level of comfort and humidity inside, we don't want that humidity condensing on that glass. And here calling out, we need a grade of at least C in order to get certified for that. So this is a nice handy reference. So this is very kind of similar to the NFRC labels that you might see on most windows, but here's the Passivhaus equivalent of that. And here we're calling out that U factor and the grade of C towards the bottom right here of the label. So as far as looking at the actual opaque systems, so here we're looking at trying to verify, any risk, or what's the risk of moisture inside this assembly, and do we have good vapor control? Having a good vapor control layer is important to manage the moisture as we are transferring or trying to limit the transfer of vapor between the outside and inside. In the winter, we're going to have the vapor drive from inside towards the outside because we have high humidity, relatively speaking, inside. But in the summer, when we do have high humidity outside, that vapor drive is going to be going from the outside into the building. So, and then similarly for the opaque systems, again, checking our 4 control layers. our air control layer. We test for water control layer, water vapor, and then thermal insulation. So something else that we do find is with a lot of these systems, because there is some very good air tightness, is trying to minimize the amount of pest control and pest management that you have to do as part of construction and even the ongoing maintenance. Because if air is not able to get through the envelope, that's going to make it very difficult for pests and insects to travel through the layers as well. So, again, as we mentioned earlier, checking what is the detailing wherever these come together. So here, as we're showing two wall assemblies coming together, do we have the appropriate detailing, and what kind of sealants and detailing do we need to do for all of these? And again, minimizing that thermal bridging, understanding every material has some level of thermal bridge to it, but really trying to dial that in and minimize that. So this is what a sample certificate might look like for a certified panel system. Obviously we've got our name and what type of product it is, where they are. And this is something to call out here is oftentimes Passivhaus, we think of single family home as far as Passivhaus because house is in the name. However, that is not really the case. Passivhaus is more about a certification and testing protocol than it is about a specific construction type. And so we can see that Passivhaus is applicable not only to single family, but also a lot of multifamily, and you can even have commercial buildings that are Passivhaus certified. So I think that's one of the big surprises to people is that Passivhaus, you can have multifamily and non-residential. But as part of this label, goes through each of the various attributes, and then you can see there's some various dots underneath, and then we've got our grading key, whether it's a full complete passing grade or we see here sustainability and air tightness in this particular product has a partial passing or a pending rating. So here, water resistance, we've got 4 subcategories that need to be met. Air tightness, there's 5 categories, hence why we have 5 dots. And there appears to be, in the air tightness, one of those 5 attributes or subtests. It was identified that further improvement is likely going to be needed for this in order to bring it into a full passing grade instead of just partial passing. We also see here the various climate zones and checking to make sure which climate zones is this assembly going to be good for. So people that are building up in climate zone 7 and 8 in the far north or far high elevations, this particular panel system would not be appropriate for a Passivhaus design. But it is perfectly fine for 5 and 4A, which is where we are here in the state of Illinois. So something else is ERV certifications. This is a fairly new test for the US version. Previously, this was only available in the international version that has recently been brought to the US. And because it is fairly new, there's presently not any certified ventilation systems, but that is likely to change here before too long now that the standard has been established. However, even if you don't necessarily have a certified, a single certified product, these are evaluation criteria that can be used. And these are also requirements that would be need to be met by most any systems that are applied to a passive house design. And so, again, looking at how do we have our speed control, understanding that we don't need, a building is not going to be fully loaded as far as design occupancy and other needs. And so we do need some of this variability built in. So here calling out, various speed controls, making sure that unit is very airtight. Something that energy recovery ventilation and heat recovery ventilation systems do provide a real good opportunity for, as compared to more natural ventilation or older legacy, just leaky designs, is the ability to filter and precondition the air before it enters the building. And so by having that exchange here, noting 75% energy recovery efficiency. So for every cubic foot of air, we want to make sure that we're getting at least 3/4 of all that energy exchanged, so that we're only putting 25 or less than 25% of that energy outside. And then, sound limitations, as Grant alluded to earlier, that seems to be another one of the features that people commonly appreciate and like about passive house designs, is they're generally not noisy environments. They're very good at isolating interior sound from exterior sound, and we don't want the mechanical systems to be providing a lot of additional noise inside the building. So trying to make sure to maintain that nice, comfortable, quiet environment. And then frost protection, and because we do have a lot of frost and cold days here, we want to make sure that these systems are able to operate well year round, and not just when it's nice and warm out. Heat pumps, this is another one where presently there is only the international standard. There's not a US standard. However, that again is likely to change as this standard gets developed. And so something that we want to make sure to call out is these are not the same as your standard heat pump or HVAC or mini split systems. These compact heat pump systems are not a product that's even available here in the US. As you can see here, they're actually combining water source heat pumps with energy recovery ventilation, and a lot of these also include domestic hot water heating. So this is your ventilation and domestic hot water with a heat pump all in one unit. So this is a fairly unique piece of equipment here, and not something that we find here in the States. I want you to be aware that this is a potential technology that might come to the States in the future, and you might want to be aware that these are out there. So this is the standard heat pump certification. Again, this is only in the international standard. This probably will be coming to the US standard here before long. But part of this, again, looking at it and checking, okay, what is the sound levels that these units are providing, trying to maintain that quiet, comfortable environment. We note here, not only do they have an indoor standard, but they also have outdoor standards. 55 decibels during the day and 40 decibels at night. Trying to make it such that you're not really noticing that this piece of equipment is there at the side of the house. We know many traditional air conditioners trying to enjoy your outdoor. That's why they put all the units, try to put them out of the way, so no one's going to be around them. When you have a quiet unit, you are able to have much more flexibility about where you locate that unit, and optimizing the location and minimizing that distance that line set is going to have to run. So, and also looking at, okay, what is the demand for energy consumption? And understanding we need to make sure that we're able to drain that condensate. And a very important thing is, the longevity of heating and cooling systems. A lot of that goes back to the ability to keep these coils clean. If you can't get to a coil, then you can't get to it to clean it. So being able to maintain these coils over time. This is probably one of those areas that commercial applications, this is one that people may be a little bit more aware of, is cleaning, being able to clean the heating, the condenser and evaporator coils. It's not something that we think about in a lot of residential applications though. So, with that, got one more, got another poll question here. So looking at first question, which products are currently certified by the Passivhaus Institute here in the US? Fenestration, ventilation, opaque panels, and heat pump systems. The second question is, what is a potentially confusing component of the product certification process? The climate zones don't match with the energy code. Tracking moisture performance is not an exact science. The Passivhaus Institute requirements use the metric or SI units, or the criteria is based on custom calculations rather than industry standards. Give it another moment here. All right, we're going to go ahead and end the poll. Let's see how we did. All right, this first one was a little bit of a tricky one. Fenestration and opaque panels are both certified by the US. Heat pump systems are Germany only, as we kind of see on that slide, and ventilation systems are also not certified. Yeah, that was a little bit of a tricky one. Again, we don't have any presently certified systems for ventilation, but that will be coming here soon. So a little bit, that makes sense why people would have picked that up. So hopefully we'll have that soon. And then the second question about what is potentially a confusing component of the product certification. Most people did pick up on, yes, it's that this is in a metric unit, not the imperial inch pound unit. So pretty good on that. And with that, turn this back over to Grant. Talk a little bit about the actual certification process.
Yeah, and I just want to start with a quick note on the nomenclature here. So both products and buildings are certified, but these are separate processes. So the use of a certified product does not necessarily guarantee a certified building, and you can make a certified building without using only certified products. To add another layer of complexity, when you look at a standard like LEED, they say that buildings are certified and professionals are accredited. Passivhaus actually uses the word certified for some professionals too. So your people, your buildings, and your building systems can all be certified using Passivhaus. I'm not sure if something is lost in translation from the international version there or not. So one thing to keep in mind with Passivhaus, currently there are two levels of certification. There's a kind of base or traditional level of certification, which they call Passivhaus Core. And then there is a Passivhaus 0, which reflects or is supposed to reflect net zero. Passivhaus 0 is supposed to build on the requirements of Passivhaus core and advance them slightly. So for example, for Passivhaus core, you can have fossil fuel combustion on site, but you need to provide electric readiness. So you may have, for example, a natural gas-fired stove, but you need to provide the 220-volt outlet for eventual conversion. 0, as is implied by the net zero connotation, does not allow for any fossil fuel combustion on site. The other big difference is that 0 requires some on-site generation to offset the energy use on site, whereas core is mostly focused on trying to minimize the amount of energy used on site. So here you can see the kind of differences in the standards, the reference standards, and how they stack up with the two columns that are the rightmost showing the Passivhaus core and Passivhaus 0 standards. So it is everything that is in all of these reference standards, and then plus a few other extra things. So you can see if we look at the far left of this chart, we see the very basic requirements that are mandated by law in terms of the Energy Code. This is two older versions of the Energy Code, the IECC 2009 and 2012. Energy Star versions include code compliance, but also build on that using these other standards. The Zero Home builds on the Energy Star requirements, and then Passivhaus core builds on top of those Zero Home requirements. And then the most exacting standard is, of course, the Passivhaus 0, which includes all of the requirements of Passivhaus core plus the ability to generate energy and the exclusion of any on-site fossil fuel combustion. When we talk about the different reference standards, so Passivhaus is predicated on some external standards. It relies on not only the internal logic, but also on some external standards that you see enumerated here. So the US Department of Energy's Zero Energy Ready Home standard is referenced by the Passivhaus standard. So too is the US Environmental Protection Agency's Indoor Air Plus label. You'll see that Passivhaus projects, as a matter of necessity, also comply with US Environmental Protection Agency's Energy Star rating. And then the standard finally references the Residential Energy Services Network Home Energy Rating System. So you'll see that HERS rating for core projects, I think, is in the 40s, and then obviously has to be less than 0 for a 0 project, equal to or less than 0, I should say. Here you can see the breakdown of a typical project team for the Passivhaus certification of a building project. The first person in this kind of hierarchy is the certified consultant. This is recommended for all product types, all project types. And this is the person who's responsible for completing the WUFI analysis. And we'll talk more about WUFI as a compliance tool as we move on here. This person is involved throughout the project, so they work to ensure that requirements are met kind of from soup to nuts. The certified building or builder is the person that's responsible for sourcing, managing, and installing critical elements of the system, and for documenting that the construction process is carried out in line with Passivhaus standards. This person also is required to track the adaptation or alterations from the project documents. As we'll see when we talk about the phases of the certification process, the documents themselves are approved, so any deviations from those documents also have to be approved. And then they are the two kind of approval professionals that come at the end of the process. These are the rater and the verifier. So the Passivhaus certified rater is required for single-family detached projects, sort of what we think of as the traditional Passivhaus project. and it's optional for attached or townhouses, whereas the verifier is required for non-residential and multifamily projects and is optional for single-family attached and townhouses. In both cases, this person visits site and performs the testing and verification that is required to indicate that the project does in fact comply with the myriad standards, which we'll talk about more a little bit later. And in both cases, whether it's commercial or a residential project, a letter of intent is required from either the rater or the verifier for the project to become certified. And I have a slide in here about the process of certification and the steps coming up towards the end. So those of you who are familiar with ASHRAE 90.1 compliance or IECC compliance will be very familiar with the idea of a prescriptive path, basis of performance path for complying with the standard or the code, in this case, the standard. The prescriptive path for Passivhaus indicates that all of the components directly meet the requirements. However, the scope of projects which can use the prescriptive compliance path is fairly limited. That is to say that only single-family duplexes or townhomes can use the prescriptive compliance path. If you have a commercial building or a multifamily building that isn't a single-family duplex or townhome, then you have to use the performance-based requirements. The performance-based requirements mandate that there is an overall level of building performance that must be met, irrespective of the individual prescriptive components. Just because you have a single family home and are able to certify using the prescriptive compliance path, that doesn't mean that you have to certify using the prescriptive compliance path. Even a single family home can use the performance-based method, which is particularly useful when it wouldn't meet certification using the prescriptive compliance path. So there is no trade-off method as in ASHRAE 90.1, but just as in ASHRAE 90.1, there's both a prescriptive and performance method to indicate compliance with the standard. So here you can see our two levels of certification, core and zero, and when each of the prescriptive and performance compliance paths are appropriate. So for new construction, core and zero projects, you can use all building types can indicate compliance through the performance compliance path. Remember that for limitations on combustion, the zero and any prescriptive compliance, so that would be a single family home that's indicating compliance through the prescriptive method, would not be able to have on-site fossil fuel combustion. The only project that would allow fossil fuel combustion on-site is a performance compliance path project that is seeking only core and not zero certification. There is also a standard for retrofits. This, I guess, is somewhat analogous to the LEED standards for retrofitting buildings. Really, the only difference between the new construction and the retrofit standards from a Passivhaus perspective is that some energy allowances can be carved out for building renovations for areas that would be particularly difficult to correct. So things like foundation insulation, which couldn't be readily upgraded in a retrofit project, you may be able to use this revive standard, which may be a little bit less exacting or may provide you with some energy allowance to account for those different requirements. The performance-based compliance path allows for the use of indoor pools or jetted tubs. Does not require the limit on the ratio of floor area to bedrooms, and does not necessarily limit the fenestration area. This is similar to ASHRAE 90.1, where the prescriptive requirements class requires either 30 or 40% window wall ratio. It's similar in Passivhaus, so the performance compliance path, you wouldn't necessarily need to indicate you had this low percentage of fenestration, whereas the prescriptive compliance path, which you'll remember is used primarily for single family homes, would have to indicate Here you can see the air tightness requirements that are mandated for the performance and prescriptive compliance paths. These can be tested at either 50 pascals or 75 pascals of pressure. And you can see that the standards vary slightly between buildings that are shorter than 5 stories and non-combustible construction versus all other building types. So one thing that sets Passivhaus apart from other standards is that a in situ whole building air tightness test must be performed in order to achieve certification. The amount of permissible leakage is dictated by the gross enclosure surface area as measured at the exterior thermal boundaries. So we talked about those control layers. It uses the surface area of the thermal control layers. This can be done at either 50 pascals or 75 pascals, but it has to be adjusted for inclusion in the energy model when using the performance compliance path. So then 50 pascals has to be used. And some areas are allowed to be taped off if for testing if their leakage is non-assembly threatening. So these are things like elevator shaft doors or fire egress doors. You have to use the untaped off version for the performance compliance path. But if you're doing the prescriptive compliance path, you can indicate compliance by taping off some of those areas. That being said, when using the performance compliance path, the untaped results have to be used for inclusion in the WUFI model. Here you can see some of the active conservation requirements. So in addition to making standards related to envelope performance, there are also requirements for active consumption. This deals with net source energy demand, and it's dictated either by the number of occupants or the number of floor area based on whether or not the project is a residential or commercial project. So in a residential project, the number of occupants that's used to dictate this is equal to the number of bedroom plus 1, and studio units receive 1 occupant. In non-residential projects, a school, a commercial building, something like that, you would use net source energy demand based on the finished floor area. So this excludes any unconditioned areas. So when we're talking about the active requirements using the performance compliance paths, there is actually a method to do mixed-use buildings. Mixed-use buildings are not required to certify as whole buildings. Components can be certified either as the residential component or the commercial component of a mixed-use building. As you can see here, there is no energy allowance for unfinished spaces. So you don't get either occupants or extra floor area for having unfinished spaces. And there are special requirements for buildings that are off the grid. Obviously, for a zero building that was off the grid, there would be no process load requirement. And then for a off the grid building using the core certification, you get 800 kilowatt hours per person per year. Here you can see the net energy accounting method for using the performance compliance path. So in this case, the source energy demand is calculated as the annual energy use net of renewable energy. That's for use from the core. If you're doing zero, then the source energy demand is calculated using the net of all non-on-site renewable energy production. So there is, for core certification, a number E. Your net source energy demand has to be below E. And for the purpose of zero certification, the net source energy demand obviously has to be below 0. So here you can see the standards for non-residential buildings. We talked about the standards per occupant for residential buildings in the previous slide. So for non-residential buildings, you can see the energy use intensity or the net source energy demand has to be below 24 kBTU per square foot per year, which is the same as 83.6 kilowatt hours per square foot per year, or in metric units, 7.8 kilowatt hours per square meter per year. The way that renewable energy requirements are measured is different based on using the performance or prescriptive path, and more importantly, based on using the core or zero path. So when you're talking about a building that is using the core path, no renewable energy is required, but you do get some credit for on-site renewable energy specifically. In the zero path, obviously renewable energy is required to the extent that it is able to be greater or equal than the moderate energy use of the building. So essentially we have to have a net zero building. It's worth noting that for those zero buildings, the renewable capacity doesn't necessarily have to be on site, but there is a multiplier you have to use. So you get the most credit for on-site renewable energy. They get a 1.0 multiplier. If you have directly owned renewable energy, but it's off-site, that's a 0.75 multiplier, the same as a community renewable energy system or a virtual power purchase agreement. And then if you get into something like using these renewable energy certificates, these green renewable energy certificates, you could only count 1/5 of the energy associated with those towards the source energy of the building. Here you can see some of the moisture design requirements. These are broadly divided into requirements for opaque assemblies and for fenestration assemblies or openings. In the opaque assemblies, there are 3 different compliance paths. There's the prescriptive control guidelines. You can have the moisture engineered, evaluated by a qualified professional engineer, or you can use the hydrothermal analysis in WUFI, and we'll talk more about WUFI in the coming slides. For fenestration, this FRSI must be met using one of the following methods, and you can see there are 6 possible standards that can be used to indicate compliance with that provision. So the last few slides of this are kind of a laundry list of the different requirements that are associated with any number of different building systems and subsystems. So on the left column, you'll see the quality of the building, and then on the right column, you'll see the requirement for that building. So the first slide deals specifically with the envelope. So there are requirements for air barrier integrity, that is, that the air barrier is contiguous behind stairs, porches, roofs, etc. There are requirements for air sealing, that penetrations between conditioned and unconditioned spaces are sealed. There's the quality check of insulation, window performance, that windows are Energy Star certified, vented attic reduced thermal bridging, that vent baffles are used in bays with soffit vents, slab edge insulation. This is dependent on which climate zone, but you have to have at least a thermal resistance of R5 to the depth specified by the International Energy Conservation Code, reduced thermal bridging in above grade walls, and then other thermal bridging and mitigation strategies. Similar requirements are provided for mechanical systems. So we talked about the balanced ventilation, that the measured supply and exhaust must be within 10% of one another. Preheat defrost required for ERVs. I think Brian talked about that in the ERV certification process. That the heating and cooling equipment has exterior locations that are designated and offer natural drainage. This goes with some of the moisture requirements that we've discussed. That return air passes through filters. That's a matter of indoor air quality. That all combustion heating and water heating systems are sealed combustion direct vent appliances. Again, these would be allowed only in circumstances where you can have on-site combustion. And even in those circumstances, you have to prove electrification readiness. Hot water heater, dedicated space, lighting, a certain percentage, in this case 80%, have to be Energy Star qualified or have Energy Star lamps in 80% of sockets. And then the Energy Star standard is also the underlying standard used for clothes drying equipment and other appliances. And then finally, there are some miscellaneous requirements that don't really fit with the envelope or with the HVAC system. such as having a water moisture managed site or foundation, water management in the walls and roofs, low emitting building materials. So this would be concerned with things like off-gassing and VOCs, compliance with radon management, pest management, and combustion pollution management, charging infrastructure for electric vehicles to support the conversion of the internal combustion engine fleet to an all-electric fleet, and then the absence of combustion equipment or its readiness for electrification, and some things like draft fireplaces are not permitted for renovation, zero, or core paths. And even where those things are permitted, you have to demonstrate electrification readiness. So for a single family house project using the prescriptive compliance path, you can actually look up one of these neat little calculator checklists that will tell you which requirements are applicable to which system. And then you can kind of go down the list and check off and make sure you meet all of the prescriptive requirements. And as promised, here is it says 3 phases. It's either 3 or 4 phases, depending on whether you consider it a zero-based index, because phase 0 is just a feasibility study and doesn't have any associated milestone. Phase 1, the milestone is that the project has to be registered. So it's mostly a phase that has to deal with paperwork. Phase 2, the design has to be certified. We talked briefly about how deviations from the certified design are allowed if they are appropriately noted. And then finally, the final certification, which takes place after the construction, that's based on the certified design. So before we move on to some of the measurement tools, we just have one more poll question for you about the building certification process. So once again, I'll read this for the benefit of those listening to the recording later. Which of the following standards is not referenced in the building certification process? The Indoor Air Plus label, Energy Star, Home Energy Rating System, LEED for new construction, or Zero Energy Ready Home? So we'll give people a second to select here.
All right. Looks like most people have answered here. We'll go ahead and close the poll.
Okay.
Share our results. Looks like the majority of you did pick up LEED for new construction is not on here, which again, this kind of makes a lot of sense because we've got our Air Plus label for indoor air quality, Energy Star and Home Energy Rating System, and Zero Energy Ready Home. Those are all specifically energy, dealing with energy type of things. LEED for construction is kind of the odd man out here. This also makes a little bit of sense because LEED for new construction initially was developed with commercial buildings in mind and has since transitioned and expanded to include residential, whereas Passivhaus started as a residential standard and has grown into a commercial standard. So. All right. So with that, we're going to touch on some of these certification tools and guides. But before we dive too far into this, is understanding that Passivhaus has some limits built in, and some of these, as far as how much heating or cooling are you allowed to do over the course of a year. So if we add these together, heating and cooling combined is approximately, what do we have here, 9 to 10 kBTU per square foot per year for heating and cooling systems. So that's a very low number. And additionally, these heating and cooling peak numbers, interestingly enough, this is fairly balanced here. Here in the state of Illinois, which makes heat pumps very attractive and very effective. And here, if I use the highest number on here, 6.5 BTUs per square foot, that means that a 1-ton heat pump under this limit would cover a building of at least 1,800 square feet. So even if you have some of these larger homes, a 5,000 square foot home, that's only a 2.5-ton heat pump to do that. So, this is one of the, I think I saw in the chat, there was some discussions about cost. And this is one of the primary methods that passive house buildings use to help manage and limit the added costs from implementing passive house technology and standards, is by focusing on that building envelope and what we put in the buildings. That really helps shrink that HVAC size. And so that can really drive down the costs of the mechanical system. So we're trading a little bit more investment in an envelope and capturing that savings on the HVAC side. And similarly here on the airtightness of the envelope, I believe it was also noted earlier in Grant's portion, looking at a standard of 0.05 to 0.08 CFM per square foot of envelope. That's comparing to the energy code of around 0.25. So this is a third to a fifth as much air leakage as compared to the energy code. So that's a dramatic difference for that, and again, a dramatic benefit. We mentioned earlier, as far as the trying to achieve these low sound measurements for heating and cooling equipment, both indoors and outdoors. If you say that across a 5,000 square foot home is only a 2.5-ton unit, that's not a very big, not a very large unit. And so we don't need a lot of airflow in order to achieve that. So that's a real benefit there. So as far as the thermal control layer, here's looking at some of these requirements, noting, I'll call out some of these as people are a little more familiar with, roofs, an R64 to R80. That's compared to the energy code, which is moving up to an R60 in the 2021 version of the IECC, up from an R49. So we're seeing, going all the way up to an R80 in our roofs. That's a substantial increase. Walls and floors are similar here, R16 to R32, depending on, that's for walls and floors below grade, walls above grade, 32 to 52. That's compared to a more typical code value of around R20. So this is quite a notable increase here. And you can see several of these others. Another common one that we see is fenestration. Our windows and doors, here calling for a 0.23 to a 0.24 to 0.13. Energy code again is just over a 0.3. So this is that's quite a dramatic difference here. Also looking at fasteners, this is where if you're dealing with thermal bridges, this is probably where you're going to deal with a lot of this is at your fasteners, and being cognizant of the fasteners. Just the fasteners alone can reduce the insulation value by up to 5%. So that can be, it may not sound like a lot, but as we've seen, a 5% inflation or a 5% raise can be quite substantial. Moving an a wall from an R20 to an R19, that's quite something. And similarly, understanding, other penetrations, nailing flanges for windows and siding and other thermal bridges. So really being aware of what these are, and are there less thermally conductive fasteners that can be used, that can help substantially improve performance over time. And there are fastener calculations and tools. Here, this is kind of a spreadsheet that goes through, and what we see here is, as far as the material, how much conductivity that we're seeing. Aluminum, being a conductivity rating of 100, if I'm able to go, down to a stainless steel fastener, that's 1/5 of the energy, and we're now seeing more and more plastic fasteners being brought to market, which can substantially improve that. So this is one of those areas that people don't always think about, how much fasteners and, just screws and nails, how much those really make a difference. But as material science continues to improve, moving towards these better fasteners can really make a big difference. We've mentioned a few different times here, WOFE or WOFE, and what they're looking at, it's designed to look at annual moisture loading in the building components. As we see moisture drive in towards the interior during the summer and towards the exterior and during the winter, what is that balance and how is that drive impacting over time? It also deals with the temperature. So we're dealing with both temperature and humidity. And so looking at analyzing the overall thermal and hygroscopic performance of this. And so WOFE does have the capability to produce the Passivhaus Institute compliance report. And here we're seeing on the right side, we're displaying the temperature at the top and the hydrologic chart on the bottom here, the profiles across the wall. And so what the line is looking at is an hour or daily simulation over the course of the day. And the bands, it's a little difficult to see, but the shaded bands in red and green show the range over the course of the entire year. How much is that drifting? So this line represents a single day, and then that shaded band represents the range over the entire year of that. So here we're looking at some of the compliance checks. Again, WOFE makes this a little bit more, a lot easier, and so can dramatically increase the speed as far as providing the documentation for Passivhaus requirements. So that's probably one of the biggest tools out there on the market as far as the performance goes. And just want to touch on a few frequently asked questions, and perhaps dispelling some misnomers here. And the first we had touched on earlier, Passivhaus isn't just for residential. We can do both residential and commercial buildings as Passivhaus, including single family and multifamily. We've often heard, because Passivhaus, one of the big primary focuses on building a very tight envelope is saying, oh my gosh, what's this going to do about mold? Because if we make it tight, are we going to cause mold? And tight buildings don't cause mold. Improper moisture management causes mold. Tight buildings allow you to have better management over moisture. So that can help you help as far as trying to limit the generation of mold. Cost premium, I know that had come up earlier. There's definitely a range out there as far as cost ranges. We have seen anything from a 0% increase, again, because we're able to trade off a better building envelope for and more insulation for reduced HVAC equipment. We've seen cost increases, cost premiums to do passive house anywhere from 0 to 20%. And again, a lot of that is going to depend on the experience of the project team. And in particular, what we have seen drive a lot of that is, if contractors think that this is something very special and I'm going to need a bunch of specialized equipment and all kinds of specialized knowledge, their pricing is going to reflect that. However, if it's one of those, as you're looking at it, you're saying, no, you do build, relatively airtight buildings already. You do good construction practices. All we're doing now is saying, let's pay a little more attention, and this is really fairly standard construction, but we're doing it to a higher level. So that can help manage some of that cost premium. How long does, there's, as Grant touched on earlier, there's some additional documentation timeline, but it's not really a dramatic draconian process that's going to be drug out very long. And having those good people on your team can definitely limit some of that. And we also touched on some of the benefits beyond energy, including some of those, noise management. A nice quiet home, a nice comfortable home is very beneficial. So just to look at a touch of some of the projects. So these are pictures of some of the Passive House certified projects around the state of Illinois. And as you can see, some of these look very dramatically different. And you can look at that and say, oh, that's I bet that's a passive house. But then others of these, you look at it and you say, well, that looks, fairly normal and basic, and, looks, there's nothing just by driving by that you look at this and you say that that's a passive house. They look like they fit very well into a community. And here's some commercial examples here too. Schools and recreation centers as passive houses. And again, we can have modern design. Probably the biggest thing that we notice here is they're not just big glass boxes. They have glazing. We have views to the outside, but it's in a judicious form and fashion. So with that, I'll take any last minute questions here. Let's see here. Looks like there's some of these are fairly specific questions. So we'll probably follow up with some of these after the presentation. Here, Brian was noting he was anticipating a quarter to a third extra cost per square foot for that. So again, a lot of that extra cost depends on how you approach it. Too often we've seen when someone hears net zero or passive house, they automatically assume it's something totally crazy and special. And so I need to add a cost premium to it. Not necessarily it's standard construction, but we're going to take it up a notch, and we want to make sure that we're using care as we do installation. We're not just going to punch something out as quick as we can, but we need to say, okay, when we make this hole, how are we going to seal it? Oh, okay, well, instead of making one giant hole, I'll make two smaller holes that are easier to seal. You know, very, very basic things like that. So, okay. Well, with that, I think we'll follow up with last question or two. But if you do have any questions after today's presentation, or you need some help with the State of Illinois Energy Conservation Code, then feel free to reach out to us at energycode@Illinois.edu. And thank you all for joining us, and have a great afternoon.